Hello, back again after a bit of a break for Christmas and New Year, and today I'm just doing a quick tour of green circuit production, showing the effect of various different modules. This is really for Boris, my Facebook friend. He was asking today about the effect of putting modules into things. So there's a bunch of different builds here for green circuits, and the one we start off with here, I should say, each of these builds is designed so that it will saturate exactly one blue belt. So it's making 40 a second, near enough. And so I was looking at how many machines were needed and how much space was taken up, how much material used to achieve that. Okay, so the basic setup in all of these is the same. I have some chests full of material. That then gets loaded onto a blue belt, and then it makes some green circuits, and then they get dumped into a matter void here. So this is creative mode in the sandbox. I've used stack inserters everywhere. It's overkill in some of the builds, but I don't care because I'm in sandbox. So some of these can be dropped down to being blue, some really couldn't. Okay, so this is your basic starter build. You've got 3 coil fabs, 2 green circuit fabs, and we're outputting to the side here so that the circuits go onto both sides of the feeder belt. That means that when we then mix in with a splitter, we're making a saturated line of chips. That's particularly important in 16 now that various things don't compress the way they used to. So this is a 0.15 design, hence the underground. In 0.16 you'd forget the underground, you'd just do a straight line of belts here because you can't get compression from insertion or from undergrounds. Okay, so how many of these do we need to saturate a full belt? Well, quite a lot is the answer. So to saturate a full belt, we're going to end up consuming a full belt of iron. So and let's go all the way up here. Here we are. So there's not a lot of iron getting up this far. There's just enough to keep these machines working. I should say, all of these rigs I have tested by adding on or taking away 1 repeat. And in all cases, if you do that, then either things back up or things run out of material. So this is all designed exactly as close as you can get to saturating a single blue belt. So yeah, here we are. So this just about gets to the point where it's consumed a full line of iron by here, which means it's just about at the point where it's produced a full line of circuits here. And the number of repeats we have is 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 cells, that's 18 green circuit makers. So 18 green circuit makers with no modules, no speed beacons or anything like that, saturates 1 blue belt. So that's 6 for a yellow belt, 12 for a red belt, 18 for the blue belt. So what next? Well, the first and most obvious thing to do is to load these machines up with production modules, productivity modules. So this means that each time an item is made, this productivity bar in the middle fills up a little bit. When it reaches the end, an extra product is emitted. By having 4 of these, there is a productivity boost of 40%. So that is 7/5 if you like doing fractions. So we're getting 7/5 more product than we would have otherwise been getting. So let's just throw these modules in without any thoughts for anything. So we throw them in. Now we're consuming a lot less input material. You can see that the iron is not being consumed at the rate it's being produced. I've kept the same number of machines, right? And by the end, we have not consumed all the iron. And because of that, we have not saturated the output belt. And that's because these machines are running at minus 60% crafting speed. So we would need to extend this out another 1.5 times, is it? I don't know, anyway. We'd have to extend it out up far enough to compensate for the 60% loss. Clearly that's not very good. Alright, what if we just went for speed? So here, we're not making use of any extra materials, there's no... Right, so we're just doing the thing quicker. And the answer is, that actually has a big improvement, right? So these machines are running at 200% of their base speed. And not entirely unsurprisingly, they are filling up the green belt using half the number of machines. So if all you want to do is fill up belts, throwing the tier 3 blue things into your fabs actually works quite well. Now, those of you who've played this game before will be screaming at me by now, saying what I should really have done was take these machines and put 1 speed in. Right. So if we look at the stats now, so this is running at minus 60% speed and plus 40% productivity. This is running at plus 5% speed and plus 30% productivity. So this is now running at ever so slightly faster than baseline and producing 7/5. So if what you're doing is converting a legacy build into one using modules, this is the way to do it. It's 3 in 1, 3 productivity, 1 speed. And that means you can basically take what you had before and get productivity boosts. But your build will not be ratioed correctly, right? Because these are now producing lots of extra coils, but we still have the same number of green machines, so one of these 3 coil machines is pretty much dead pretty much all of the time. So what can we do? I could have built a nice example of 1-to-1 green to coil here. I ran out of interest. What I looked at then was bot builds, but you could do essentially the same thing with belts. Okay, so here we have a bot build which is failing to saturate a green belt. So we have basically this coil machine is being fed with plates. It's going out to a box. That box is also requesting your iron plates. So then those iron plates and coils are going in here, and then they're being chucked out to a provider chest, an active provider, which is then being used to attempt to saturate this belt. And you can see this doesn't saturate, right? So I've got 1, 2, 3, 4 green circuit makers here, all fully speed beaconed, and it's not really doing the job. Okay, so 4 is still a big improvement from 18. Here's a build which does manage to saturate. So this is managing to saturate 2 blue belts, and it's a belt-fed version. So what we're doing is we're staggering the beacons so that they hit as many machines as possible. So the line of copper comes in, it grabs copper, then because it's got 4 productivity modules, that's enough copper cable to satisfy a single green machine, minus a tiny bit. So that green machine then goes off and makes lots of green circuits. It's eating iron plates from here, and it's dumping the green circuit into this underground, which allows us to skip underneath the beacon and get the product out. Okay, so that's fine. And this is encouragingly consuming copper and iron at roughly the same rate. Remember, we're getting 7/5 boost on output product here. So we're never going to consume the entire line of iron, because 1 line of iron consumed will produce 7/5 lines of iron, 7/5 line of green circuit. So by adding productivity modules on a belted setup, you're actually ending up needing sometimes more belts for the output than you have for the input. Sorry, I saw that, had to kill it. Uh, so that's kind of weird if you're used to, you know, always having less output than input. Um, so yeah, that's really where we're at with this one. And here we have 1, 2, 3, 4 green circuit machines saturating a blue belt. Okay, this is the drone version of the same thing. So here we have our straightforward line of beacons, and then our line of beacons has your assemblers down the middle. So the green circuit assembler has an input for plates, and it is direct fed. It's direct fed the coils. The coils request copper plate, and there's one extra coil machine on the end just to make up for the greens using slightly more than one coil can produce, even with productivity modules. And this saturates a belt. So you've got 1, 2, 3 green circuit machines, 3 green circuit machines, 4 coil machines, and that produces a blue belt of green circuit. So this is, give or take, as good as you can do. Now this obviously tiles and scales, so you could produce as many green circuits as you wanted with this. There are ways to achieve this with belts. So these beacons overlap quite a lot with the machines they're serving. You can move them one square out, or you can stagger them in a sort of crocodile zigzag, and that gives you space to bring in the materials you need. You can either thread underground belts through. So if you see this, these are both requiring copper plates, so you can bring an underground belt through, which comes up and then drops down again. So zigzag it through like that. On this side, it's not quite that simple because you have you've got your iron and your green circuits needed. So there are options for this, but the simplest one is to let's just show you. Right. So if I have a beacon and I have an assembling machine. Here, right, so this assembling machine is outputting. So what we can do then is output to an underground, like that. And in the meantime, we can be threading through the materials it needs to consume using an underground. That's in the wrong place. Let's try again. Right. So then it can be consuming its iron plates. Like that. So the iron plates go up, and then the green circuits are dumped out the side. So that does work, but it makes your builds really messy, and you can no longer tile them side by side. Okay, let's just kill that off. I don't know if I have construction bots around. We'll see. No, I don't. Okay, so that's a brief tour, really. So these are your sort of options. I don't know what... Oh, sorry, I clicked on the wrong thing here. I don't know where the... Oh, it's shift here, isn't it, to get rid of auto research. Yeah, so these are basically your options if you're doing modules. Right, well, I hope that was interesting, or informative, or at least not entirely boring. So, Boris, thanks for the question, and that's my answer.